We're just going to learn on that, and then there's no point learning anymore. Then we train. We run it through like whatever model we happen to pick. You know, is it a neural network? Is it going to be like a genetic algorithm? Whatever we want. And you know, we can use different data sets. So we slice our data set. So say you only have one data set, you can do crazier things where we slice it up and we make sure we're not just learning the data set. We want to make sure it's extensible, it's genericify, or we can genericify it. And then finally, you know, you go play the stock market and you win $1 million. The end. I don't know why more people don't do this. All right, so anyway, let's talk about neural networks. So this is, you know, we had the overview of machine learning. There'll be a quiz, but now we're going to talk about neural networks. Okay, so neural networks is one of those things that's inspired by a natural system. Okay, and one of the natural systems that we're all familiar with is the human brain. So if you hold a strong enough light up to your head, you'll see things like this. So you know, we have this idea of, you know, activation coming into a neuron and then activation going out, right? So certain things act on a neuron and then it does something magical and then it sends electricity out. And so there's lots of these going on inside of your head. Each neuron receives input from other neurons, and this is kind of squashed, but anyway, you get the idea, right? So like there's, you know, neurons and then, you know, some kind of like they cascade with some kind of like activation energy or some kind of activation weight. All right, so neural networks are based on this kind of principle of like the single neuron, okay, but there'll be just like a network of them, okay? So what we're going to do is we're going to say the weights between these neurons are going to change. That's the basic idea in response to, you know, like the error and everything like that. So the thing about neural networks is that, you know, they're mysterious and we're like, hey, humans can recognize, you know, can understand language and control their bodies and everything like that. There's no reason why neural networks can't do it. So we're going to model that up like that. Oh, this is supposed to be, I think, 10 to the 11th and 10 to the 4th, something like that. Yeah, so anyway, we're highly connected. Well, all right, well that's something to talk about later. But we have at least 1,000 neurons in our heads. All right. So anyway, so you know, this is highly parallelized, right? So our head is like full of all kinds of like goop that is highly parallelized neurons. So let's zoom in on a specific one and talk about it from no longer the gray goo style, but more of a, you know, what we're actually talking about with neural network style. So we have some inputs and then we have the neuron itself, and it has some kind of like function inside of it to say like, based on my inputs, how much do I spit out, right? So it has some kind of activation function, right? And there's some other stuff in here. There's like a bias unit that doesn't necessarily feed in from the neurons behind it. It's like a constant and things like that. And you'll see some of that in the diagram.